Okay, so hello and welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya, and today I am going to start the last topic in the series of rotational motion, that is toppling. Okay, and hello, so I am Ravindram and let's begin this lecture. First of all, let's understand what is toppling. Okay, see, many a times you have experienced this thing that suppose a water bottle is kept like this, and if you try to push it here, then instead of moving, instead of sliding, what happens? It topples, right? Sometimes you must have experienced this thing that suppose this is a water bottle, and if you apply a force here, capital F here, then what will happen? It will start sliding. Okay, sometimes it might happens that this is a bottle and you apply a force F here, then instead of sliding, what it does, it topples. Topples means like this, it starts rotating like this. Okay, so instead of sliding forward, it starts toppling. So these are the situations. So let's understand when does these things happen. When does a body topple? When does a body slide? When does a body topple before sliding? When does a body topple after sliding? Right, all these conditions. Let's try to understand what is toppling. So it is written that in many situations an external force is applied to a body, right, to cause it to slide along a surface, right. The external force, the basic job of the external force is to slide the body along a surface, right. But sometimes the body may tip over the surface before even the sliding begins. Okay, so let's understand those cases. So first of all, let me take a very simple case. There's a smooth horizontal force. Sorry, this is the block. Can you see this? This is the block, and this length is A and this length is B, and mg is acting on its center of mass and normal is in line with mg, right? Why? Because the pressure is uniformly distributed, normal will definitely be in line with mg. So what is the net force along the vertical direction? You will say, sir, mg minus normal is 0. And what is the torque about any axis you choose? Suppose this is my axis. So what is the torque about this axis? So you will say, sir, net torque will be 0. So there is no torque, there is no vertical force, there is no horizontal force. Simple, this body is at rest. There is no rotation or toppling of this body. Now let's take another case. Suppose it is kept on a rough surface and a force capital F is applied here. Okay. Now this capital F is in line with center of mass. Let's make sure. So this is the basic case, right? Now what might happen? What might happen if you look at this diagram very carefully, that as soon as you apply this force F, immediately friction will come into action, right? Which friction? You will say, sir, static friction will come into action in order to stop the block from sliding, right? Now what is this? You will say, sir, mg is already acting here. Now you tell me, if I say mg is acting downwards, okay, so if normal is acting here, suppose if normal is acting here, then what will happen? You will say, sir, about this axis, the torque of capital F normal and mg will be 0, but there will be a torque of static friction. There will be a torque of static friction, and if there is a torque of static friction, then this body will topple like this. Can you understand? This static friction is trying to give a torque in this direction, right? Give a torque like this, minus k cap, and the body might topple, right? So in order to avoid that toppling, what can be done? This normal will say, I will shift my position in such a way so that I can stop the torque of this particular static frictional force. Okay, or otherwise we can choose other axis also, no problem. So are you understanding this? So let's begin once again. See, suppose we have this block, right? This is A, this is B, and you have applied a force F here. Already there is mg here, and you have one more force, that is static friction in this direction. Now what we will do is we will say normal will shift its position, let's say by a distance x, such that the torque of this static friction is balanced by the torque of the normal. Or one more thing we can do, we can say, let's say that this is our axis of rotation, right? Can you see this? This is our axis of rotation. If this is our axis of rotation, then torque of two forces are definitely 0. Number 1 mg and number 2 static friction. Okay, so you will say torque about this axis, let's say this axis is P. So torque about P will be, there will be two torques. Number 1, torque of capital F. Now what is the distance of capital F from this axis? Perpendicular distance, you will say, sir, B by 2. So it will be F into B by 2. Now how will be the torque? The torque will be like this, minus k cap, right? Minus k cap. So I will give it negative sign. Normal torque will be like this. About this axis, normal torque will be like this, outside plus k cap. So plus normal into x. What is normal? Normal equals to mg. Now torque about point P will be minus F into B by 2 plus mg into x. Now what we want, we don't want the body to topple, right? That is why the normal has shifted its position. Now that means torque about point P must be 0, is equals to minus Fb by 2 plus mgx by 2. Do you understand? Sorry, mgx, not by 2, mgx. Okay, so finally what you will do, you will say, sir, in this situation mgx is equals to F into B by 2. Now what is F? F is 2mg by B into x. Can you see this? So this is the final force that you are getting. So if this is the force, this is position x, x is the position where it will shift. Now the normal also has a limit up to which it can shift. Can you see that? At max, normal can shift up to this point, up to this edge. After this, normal cannot go beyond it. So see, so normal cannot go beyond this point. So your axis P can come up to the edge, that's all, not beyond the edge. Okay, that means capital F will have a maximum value if you don't want this block to topple, right? So you will say, sir, the maximum possible value of F so that it doesn't topple will be 2mg by B, and the value of x will be a by 2. Can you see that? The maximum value, what is this distance? You will say, sir, a by 2. If x is a by 2, then f is maximum. I hope you can see. Oh, 2 and 2 will get cancelled, right? And the maximum possible value will be mg into a by b. Do you understand? So this is the maximum possible value of the force that can be applied on the center of mass so that the block doesn't topple. If your force is greater than this value, if the force applied on the center of mass of this block right now is greater than this value, then definitely the block will topple, nobody can stop it, right? Are you understanding? Yes. Okay, right. Now let's understand some more situation here, some more points here. Suppose in the first case, F is less than F max, obviously the block is not sliding, sorry, the block is not toppling, right? If you ensure this, the block is not toppling. Let's try to understand one case where F max, the maximum value of the force that is possible in order to topple the block, if it is greater than F limiting, that means the friction force, the maximum value of the static friction. That means what will happen, this value is greater than the limiting value, that means the block will slide first. Yes, the block will start sliding. The block will start sliding before it topples. Do you understand this situation? So what is F max? mg into a by b greater than mu mg. Okay, so mu is less than a by b. Now this is a very important condition. Now see, one more thing. You might say, sir, if f is greater than f max, then what will happen? Will the block slide? See, if it is acting on center of mass, then we have one more advantage here, students. If you can understand this thing. See, suppose the block has started sliding. So the friction is constant. Friction is Fk or Fl, whatever it is. Friction is constant, right? And the block has already started sliding. The block is moving right now. So this is your capital F. This is your mg. Now, instead of taking this point as your axis, we can take the center of mass of the body as our axis. Okay, this is our axis of rotation. Now, let's say this f is even greater than f max. Okay, but if the situation is this, see, f max is greater than f limiting, f max is greater than f limiting. That means what? F max is greater than f limiting. That means before toppling arrives, before toppling happens, the block will start sliding, right? So here the block is already sliding. Try to understand. The block is already sliding here, right? And even in order to protect it, maximum normal will shift here. At max, normal will shift here, right? Now, even if your f is greater than f max, normal cannot go beyond it, right? F is greater than f max, normal will not go beyond it. The body has already started sliding. So if you take this as your axis of rotation, still normal has stopped it from sliding. Are you understanding the fact? So in this particular case, if mu is less than a by b, then no matter how much is f, body won't topple. Why I am saying this? Because right now the torque of this force and this mg is zero about this. So balancing of torque is only done by normal and this. Can you see that? The balancing of torque is done only by normal force and this. Let me say, you will say that n into a by 2 is equals to fk into b by 2. Okay. So mg into a is equals to, let's say, mu mg into b. So mu is equals to a by b. So for this condition to happen, that means the body to topple, mu should be at least greater than equal to a by b. This condition will arrive. And if mu is greater than a by b, then it will topple. If mu, so number one, in this condition, if I say number one is if mu is greater than a by b, body will surely topple. Body will topple. Okay. If mu is less than equal to a by b, will not topple. I hope you are understanding this point, right? Clear? Clear. So here the only fact is that even if f is, because f is acting at center of mass, if force is acting somewhere else than center of mass, then obviously even after sliding the block may topple. But if the force is acting on center of mass, then no matter how much is the force, if you fulfill this condition and this condition, if you fulfill this condition, then the block will not topple. Even doesn't matter how much is this force, the block will not topple and it will continue sliding, right? So remember this condition. Let's do a simple question here. So this is the question we can see. Find minimum value of L so that the truck can avoid the dead end. Okay. Without toppling the block kept on it. Okay. So this block doesn't have to topple, right? See, for example, for this truck to save itself, it will apply brakes. If it applies brakes, then there will be acceleration in the opposite direction on the truck. So if you sit on the truck and observe this block, you will say, let's draw the FBD of the block. Now this is a non-inertial frame. In the non-inertial frame, you will say, sir, mg is acting downward and one force MA, which is what our pseudo force, will act in the forward direction. Now this pseudo force might topple this block. Okay, if we want to just save this block from toppling, we will ensure that normal comes here. We don't care about sliding right now. We will ensure that normal comes here, and we will take this our axis of rotation, right? And we will say that in order to save this block from toppling, torque about P must be 0. That is what? Maximum is what? N into what is this distance? What is this distance? B by 2. So N into B by 2 must be equal to Fs into what is this distance? H by 2. So what I am doing is, magnitude wise I am equating the torque of Fs and normal about this axis, because anyways the torque of friction about this axis and torque of mg about this axis will be 0. Why? Because these two forces are already passing through the axis, right? So this will be cancelled. So you will say that normal is equals to mg into b is equals to ma into h. Cancelled. Do you understand? So what is the acceleration? You will say, sir, acceleration is b by h into g. This is equation number 1. Now you will say its velocity is v, distance l in which it has to stop. So you will say initial velocity v square is equals to u square plus 2ax. We already know that, but here final velocity is 0, initial velocity is v square, a is negative, so minus 2a, distance x is equal to l. So what is a? V square by 2l, number 2. Now we can club these two equations and say v square by 2l is equals to b by h into g. Okay, so what they want? Minimum value of l. So minimum value of l will be v square by 2 b g into h, right? So this is the value of l, so that the block will not topple. Okay, so minimum this should be the value of l, right? So I hope toppling concept is understood by you. This is a very simple concept and easy to understand. Or you can practice some questions over this also. So that's all for today, students. Thank you so much. Subscribe to our channel and keep learning infinitely. Thank you. Tada. Bye bye.